All right, guys. So there's a lot about anthropogenic climate change and ozone depletion that's going to take way more than 5 minutes to explain. They're very big, complicated subjects that go over like 100 years of history. I'm going to try to explain it in like less than 5 minutes, so buckle up. First thing that we've got is the sun right here. And what's coming out of the sun, you've got lots of different types of radiation coming from the sun. There's X-rays, gamma rays, visible light, heat, all sorts of stuff. It's all radiation and it's all in wavelength. Now, what you need to focus on is super shortwave radiation coming from the sun. X-rays and gamma rays, that's a different conversation. Shortwave radiation coming from the sun. It goes through the Earth's atmosphere. We got Earth right here, and this is Earth's atmosphere. It's going to come through, hit the Earth, and most of that radiation is going to get re-radiated back into space, typically. If we had no atmosphere, the Earth would be just an icy ball of frozen death because all of that radiation would just bounce right off the Earth and back into space. Now, what happens is that radiation hits the Earth and is going to re-radiate at a longer wavelength, like heat, like infrared, okay? Now, if this was not here, all that would just radiate back into space. But we have molecules in our atmosphere that will, when in contact with that heat, trap that heat and then start to re-radiate it in the atmosphere. So what happens with CO2, CH4, H2O sub G, Cfcs, chlorofluorocarbons, and nitrogen dioxide is that when they're contacted by this radiation, the molecule starts to vibrate. And some molecules vibrate in multiple directions, like CO2 and CH4, that are vibrating in all directions and re-radiating this heat, this radiation that we perceive as heat, in the atmosphere. So it essentially works like a blanket, but the heat is not generated by the Earth and trapped by the blanket, right? So when you get under the blanket, when you go to bed at night, then the blanket is not warm. The blanket does not generate heat at all. The heat comes from you, right? And what the blanket does is trap your own body heat to make you feel warm. Well, that's kind of what's happening here, but a little bit different because the energy is actually coming from space, coming from the sun in super shortwave radiation, and that's going to cause these molecules to vibrate and then keep the atmosphere warm. And that's what allows us to not freeze to death and die and allows all the life on Earth, which is fabulous. However, if we add more CO2, more methane, more CFCs, and more nitrogen dioxide, then that is like adding extra blankets. And you, just like getting in your bed, one blanket may be fine, 2 blankets in the winter, great. If I start putting 5 blankets on there, you're like, okay, back off, it's too hot. Well, that's exactly what's happening as we add these molecules here, CO2, CH4, CFCs, and nitrogen dioxide. The Earth gets too warm, and then it's just a chain reaction. You just get hotter and hotter. Well, that's exactly what would happen to you in your bed, right? If I put 5 blankets on you, you'd be like, okay, it's kind of warm. And then after 20 minutes, you'd be like, okay, seriously, it's not cool anymore, do it for the vine. And then, then you're too hot. But it's like a chain reaction. You can't stop it. The only way is to get rid of some of these molecules and get them back into the Earth or sequestered somehow or another. That's what has led us into the science of carbon sequestration. Carbon sequestration, to sequester means to like take it out and hold it, right? And so, so that's where we get into the concept of carbon sinks and carbon sources. So like a carbon source would be fossil fuels. A carbon sink would be something like the rainforest, coral reefs, things like that. But if you cut down the rainforest and you destroy the coral reefs and everything else, well, there is no way to sequester, to mitigate some of these molecules in the atmosphere, and it all runs out of control, and then you have a positive feedback loop, which is what in another video. Now, let's talk about this one, CFCs, chlorofluorocarbons. We've touched on CO2 in the positive feedback loop video. We talked about CH4 methane and how that's increasing and why, because as the Earth globes and decomposition increases, makes more CH4. Let's talk about CFCs. CFCs have a very special and very destructive role. Take it over here. So CFCs is the only thing that involves both subjects of stratospheric ozone depletion and anthropogenic climate change. Anthropogenic meaning man-made climate change, so the climate's changing because of our activities, and stratospheric ozone. This is not the same thing as ground level ozone when we talked about PANs, photochemical smog, car exhaust, all those things. That's ground level ozone. This is the ozone layer up in the stratosphere that keeps us all from burning alive and having cancer and absorbing all this toxic radiation. CFCs are in the middle. They actually are a greenhouse gas. They do re-radiate a lot of heat, and they destroy stratospheric ozone. The reason why is because ozone works like this. I'm going to try to explain this with my hands. Ozone is O3, right? You got 3 oxygen molecules like this. It's a highly unstable molecule, so that radiation comes down and breaks it into 2 and 1. You got O2 and a free radical oxygen. It immediately reforms to make O3 again. Radiation comes in, it absorbs that radiation, breaks into 2 and 1, and then immediately reforms to be 3 again. And so every time that happens, then it is absorbing some of that UV light, okay? So up in the stratosphere, ozone is good because it's not like blocking UV light, it's actually absorbing it and the molecule reforms. Now, chlorine and fluorine are ultra reactive, super reactive elements. And when those get up into the atmosphere, the CFCs break down, and then the free radical chlorine and fluorine molecules start binding with that free oxygen. So you've got ozone, breaks it apart, and now this is a stable element, O2, like you're breathing, okay? Now that free radical oxygen is free to bind with chlorine or fluorine. And then when that happens, it's never going to reform into ozone again. And so that's how CFCs destroy the ozone layer. But don't forget that they also cause global warming. That's why CFCs are illegal in the United States. However, they can persist in the atmosphere over 100 years. Stop.